Hey guys, welcome back. This video right here is to help us get ready for our assessment that we're going to have on graphing parabolas, which will probably be Wednesday. I'm still kind of debating on how I'm going to do that, especially with this distance learning. We may have like a little portion like of a test. I may have you do a little video of you recording yourself graphing a parabola. May have a little bit of both those things. I'm not sure what I'm going to do yet, but Wednesday we'll have some kind of test or assessment. So these notes today and tomorrow we'll kind of do two little review days to kind of help get you ready, and then you have time to ask questions too if you need. Zoom, email me, whatever you need to do, contact me if you still need some help. Hopefully you're able to print off this note sheet right here from the folder and from the assignment posting. If not, you can always just take notes, obviously, on a separate piece of paper, but there are note slides here that you could print off, or somehow kind of do a notability while maybe you're able to watch the video in some way on another device or something, or kind of go back and forth, but then you could fill this in too and use that as notes as well. But this is kind of help just go over a lot of things that we did and maybe get you ready for the test. At any point too, you can kind of pause and maybe fill in some of the gaps yourself here, but you can see the first thing I've got is just some of the 5 steps that we've kind of talked about of how you're going to graph a parabola. What are the main things you're looking to do? Number one there, first thing to think about is, remember, you're trying to look at, but just by looking at the equation, there's certain numbers you can look at to see how it's going to act. And remember, A and C are those particular numbers in the equation that are going to help us. If I write an equation down here just to give us something to look at, y, ooh, that's a big blobby type writing. Okay, we're going to go with it. Y equals 2x squared. Oh, it's too blobby. Forget it. Yuck. Okay, let's try it again. I'm going to decrease the size a little bit so I can do something a little better. Let's go with this one. All right. Y, oh, come on, buddy. Work with me. Y equals, let's say it's negative 2x squared plus 4x minus 8. Something like this, okay? Remember, A and C are these numbers here, the leading coefficient. And then, of course, the middle one is B, and then C is the back one here. And especially from those, though, you can start to already maybe get an idea or picture in your head what is going to take place when you graph this. A can tell you a lot, right? It's negative. That's important. Reminder that also is going to be some kind of, because it's a number that's bigger than 1 in terms of the absolute value of it. It'll be a stretch, so it'll be a little skinnier. And then C also just keep an eye on where it's going to be crossing the y-axis too, right? Negative 8. So those can kind of just give you an idea of what to picture in your head before you start putting pencil to paper. If you're not noticing those things, then especially as you start graphing, something's going wrong, right? So those are definitely things to consider. Okay, you can picture it's going to be upside down or right side up, and all those kind of things in terms of the shape. So those things can help first of all. Number 2 here, find. For sure you need to find the vertex. That's the most important point. They sometimes call that a critical value as well. You'll see that in the homework today or in the future too in other math classes. Sometimes that's called a critical value, so just know that, or a critical point. Find the vertex, and then from that you can draw the axis of symmetry. One of the next slides here, I'll kind of go through us graphing again too, just so you can see like me go through the steps of what it should look like, and I'll remind you all these things too. But here, just first the notes. See if you can remember yourself what are the steps that we try to do, and then we'll enact them. Number 3, build your table. Remember that I like you to find your vertex and then build a table around the vertex and find at least 5 points if you can. So when you're making a table, maybe something like this, right? X and Y, and let's say you found the vertex of some parabola was 2, 4, whatever it is. Well, then again, maybe we'll put 1 and 0 up here and 3 and 4 down here, and maybe just kind of label yourself. This is the vertex, and when you build around that, you'll see that mirroring kind of pattern, which is nice, and that can help you find more points too, or find especially when you start making the parabola, and then I just have to find 1 and 0, and that can help me with 3 and 4. Point number 4 kind of says that as well, right? Use the axis of symmetry to find the additional points. So let's say, again, it starts to, I'm just kind of making up numbers here, but let's say this starts to be like 7 and then 12, right? Well, then again, the other side, when you see that in the graph too, it'll be 7 and 12 as well. If this is the vertex, that shape should, again, mirror on each side of the vertex, on each side of the axis of symmetry. So that's why finding that point can be important, the most important first of all, and then you can build around that, okay? And then point 5, we kind of emphasize this towards later in the chapter, but when you factor the equation as well, if it is able to factor, that can find us something called, we hear a lot of different terms for it. The x-intercepts, if you're looking at the graph, it's the x-intercepts of that particular graph. We also call it the roots. There should be an S there, but roots. Or sometimes you're seeing it here called the zeros of the graph as well. So just know there's a bunch of different ways they term that. But in particular, when you're looking at it, it's the x-intercepts where the graph crosses the x-axis. And there could be one of those points, there could be two of those points, and sometimes there's none of those points. But if it does factor, that's what it'll find us. Okay, and then lastly down here, this our little formula to help get us going. We talked about how important the vertex is, right? We mentioned it a bunch of times up here and how it helps us. Well, the formula to help start finding the vertex is negative b over 2a. That will find us the x-coordinate, and will also find us really the axis of symmetry. And then once we've found those things, we can start building our table and getting into the graphing aspect. Okay, slides 2 and 3, I'm just going to go through kind of quickly, but just other reminders about A and C and how they act, and if that does kind of is slowly coming back to you here. If there was something that ever said compare the functions to the graph of the parent, right? We've done this in the past, and again, this is, again, thinking where that A and C comes in. Is it a stretch, reflection, shrink, translation? What are those things? These numbers can tell you before you even start graphing. Remember, something like this we would call a vertical stretch. I should probably put the word vertical there as well, but just importantly, it's a stretch. This number is bigger than 1. So, again, just the parent, just kind of briefly drawing what that would look like. Maybe here's the parent function, right? Close to that, okay? Mind that it's not perfect, but a stretch means it's stretched vertically, so it actually makes it steeper, just like a higher number for a slope makes it steeper. That's what happens in a stretch. It makes it look skinnier is what it seems like. I know stretch almost seems backwards sometimes for what it should be, but it's because it's stretched all the points higher. So anything bigger than 1 makes that. If it's less than 1, like this 1/3, this is called a vertical shrink. Okay, remember what that actually does in terms of the shape is it makes it wider. Again, what it's really done is it's shrunken all the points down closer to the x-axis, so they all get pulled down, actually this way, down towards this axis. Okay, so that makes it, that's what they call it, a shrink. It looks like it gets wider. If you think of that, that's okay, but shrink is actually the word. So you would say, okay, that one's between 0 and 1, right? It could be a fraction, it could be a decimal. Just make sure you be careful about thinking fraction, because remember, if it's something like y equals 5 over 3x squared, that's a fraction, but this would be a stretch, because remember, this number is actually bigger than 1. So just be careful about saying fraction. Nope, we're talking about numbers between 0 and 1. Could be a fraction, could also be a decimal. Okay, something like this. Since it's negative, since a is negative, I don't see a number there, but it's like a 1, right? This would actually be a reflection, first of all. All right, sad face, downward facing parabola. I'll just draw a little one right here, actually. So sad face, you can draw one on the graph if you want, but this will be a reflection. And the +1 means that it'll be a translation as well. Okay, this will move somewhere along the graph, along the y-axis. Okay, and of course we can have combinations of these things. So this could be, right, this one could be a stretch and a translation, right, because this number is bigger than 1, and it's going to move it down the graph. Okay, this one would be it's negative, and it's a number between 0 and 1, so this would be a reflection and a shrink. So just realize we can have combinations of these things. In general, you should be able to answer for any problem that you look at even today. You should be able to answer these questions. Okay, if you can, that's a good sign going into our assessment on Wednesday. But all those things are things we've talked about. How does it act based on the numbers? What's going to happen with the parabola? I know another question that came up a lot when we were going through problems was people asking about questions where it asks about a maximum or a minimum value or for these parabolas, and sometimes they call these critical values as well, just so you know. It's kind of where the graph turns around, right? Or for these problems we're doing, it's the vertex, okay? It's that top point or bottom point, okay? Just by looking at an equation, you should be able to tell if it has a maximum or minimum. All right, and that's, again, based on especially that A value. Since this is a positive value, we know this is a normal, smiley, happy face parabola. Okay, and then that means it's going to have a very bottom point. So the vertex, when you find that is that's the critical value, or that's the minimum in this case, because there is a lowest point on it. I can plug in many values of x, And as I plug in bigger ones, the graph's going to go up and get higher values. As I plug in ones that are further negative, it's going to get higher values. But there is one point, one value, the y value in particular, that is the lowest of all. In this case, it looks like it's 3, -1, just by looking at that graph. So the minimum value would be -1. No matter all the things I could plug into x from this equation, -1 is the lowest I could ever get. So there is a minimum. Okay, and sometimes they have you find it, and sometimes not. But just realize if you're finding it, it's just like finding the vertex, right? On the other side, okay, this particular problem, right? By looking at it, you should be able to tell, oh, that one's going to have a maximum point because it's a negative leading coefficient. So that means it's a frowny face. It's negative, right? It's a negative parabola. And so it has a very highest point. Here it is right here for this one. Okay, and then I can find that, again, that y value. It looks like it's like 2 and maybe 8 is what the vertex would be. 2, 8. And so no matter what I could plug in, all the different x values I could plug into this particular equation, 8 is the biggest value I could ever get out of it. So that is my max value. So that's why we say this one is a maximum, and that'd be the value for it. And you just find the vertex would be the get you on the track for finding it. Okay, and on this last slide, I've got 3 equations there. Again, right now you could pause the video right now and try graphing them if you want. I'm just going to graph one of them. If you want me to graph more or something, you can, again, email me, Zoom me, or something like that, and I can kind of guide you through in case you're having a little trouble with it. Or, again, on today's assignment, too, that'd be a good way. I will post another video also that helps a little with the assignment for today. But let me just graph one of these. Again, I think for good practice, though, you can graph all 3. I'm just going to pick the second one for now. Okay, I think that's kind of a nice one to go with. So I'm going to graph this one. I'm going to show my work kind of down below here and make myself some more space. But I'm going to walk through our steps and kind of talk through them. Again, what should it look like when you're graphing a parabola on Wednesday for the assessment? Again, you might have to make a video kind of thinking of this, you doing this yourself too. So you need to know all the steps you need to do. We talked about our steps. Step 1 was first look at A and C, just to give yourself even a mental picture of what this should look like. A is +2. So first of all, even in my head, I can think, oh, positive, yay, smiley face parabola. Okay, it's going to be right side up. It should be, unless I plug the points in wrong or something. And again, that should be a telltale sign then. If you're getting your points to face down and your parabola seems to face downwards, something's going wrong. Okay, so based on this, it should be an upward facing parabola. It should be kind of a skinnier one compared to the parent function because it's a stretch, right? And then also the y-intercept is +10. You can even just kind of make a note of that yourself right now. Like, oh, well, I know it's going to be 0, 10 is even one of the points. Okay, so if you want to put that on there, you can. But that should just be what to expect. It's going to go through there. Okay, good. So A and C, we kind of know what it's going to be like. Now I can find, I think step 2 is find the vertex, right? So I can review myself the steps. Find the vertex, -b/2a. Here's A, here's B, here's C. This is a standard form. Just kind of a side note, we'll talk about this soon too, but this is a standard form quadratic equation, okay, for what we're graphing. We'll talk about, there are other forms too, maybe we'll get into them a little more, but these are called standard form. When I have them where there's no parentheses or anything, everything's is simplified as much as possible. I have a trinomial here, so this is a standard form quadratic equation. So, -b/2a to find the vertex, -12 over 2 times 2, which is 4. Okay, I'm going to reduce that down to -3. So -3 at my vertex starts at -3 something, right? And that also is my axis of symmetry, then the equation for it, x equals -3. I'm going to draw that in with a different pretty color here. Let's go with blue, and I just got to draw the axis of symmetry. And I'm getting better at doing these on the iPad. Not bad. Okay, don't judge. Looks pretty good, I'd say. Okay. Better than some of my other ones. So there's my vertex is going to be somewhere along there. And I know it's an upward facing parabola. It's going to go through 0, 10. So it's all starting to come together pretty good here. I'm going to start making my table over here as well. Okay, x, y. My vertex is -3, and I still got to figure that out. Okay, so this is my vertex. But I'm just going to start putting kind of my table together here. -2, -1, -4, -5. Okay. That still will get me going in the right direction. I got to put -3 in, so let's see what happens when I put in -3. So 2 times -3. I got to put it back into the equation to find the y coordinate. 12 times -3 plus 10. Okay, let's see what I get here. 3 squared is 9, doing this part, times 2 would be 18, plus, and then this part gives me negative 36 right now, and then plus 10 still. So 18 plus negative 36 gives me negative 18, and then plus 10, I'm getting negative 8 here. So it's negative 3. Oops, I said the right thing, but I wrote the wrong thing. Negative 8. Well, I'll just erase. Negative 8. Okay. So there's my vertex. If I was finishing this point off here, negative 3, negative 8. I'm going to plot that point. It's way over here. There's my vertex. And it's starting to feel right because it looks like it's going to be kind of skinnier, right? Like we said, because it's a stretch. And my y-intercept is positive 10, which, yep, it should stretch up that way. It's a smiley face parabola, so it should go up that direction. So that seems to be fitting together pretty nicely so far. Okay, I've got to plug in some other values here and figure it out. So I got to plug in like negative 2. Maybe I'm going to use that right here, what I've got, and just kind of erase and use some technology magic here. So I'm going to put in negative 2 now, negative 2 in for both these spots. Negative 2 squared gives me positive 4, times 2 gives me 8. Okay, and then plus, let's see, this would be negative 24, and then plus 10. 8 plus negative 24 gives me negative 16, plus 10 gives me negative 6. Okay, that's a good sign. And then hopefully I should get negative 6 over here, and I bet I do if I plug it in. I think things are going well. But that's a good sign too, right? Because if it's negative 2, negative 6, yep, it's going up in this direction. I can use the axis of symmetry to get a point across from this, yep, because that should make sense. And that's kind of showing, yep, that it's going up the right way. So if I had a point that was more negative, like negative 10 or something, that'd be a problem. Then I'd be going the wrong direction. But so far, it's working out. Okay, good. Let's plug in one more here. Let's plug in negative 1 and see what I get. Negative 1 into both of these spots for x, okay? Let's see, let me make it a little better. Negative 1. Negative 1 squared right here gives me positive 1 times 2, which is 2, okay? 12 times negative 1 gives me negative 12, and then plus 10. 2 plus negative 12 gives me negative 10, plus 10 gives me 0 in this case. Okay, so this is 0, and that's 0. And that also tells me something here I'll mention in a second, but let me go plot them first. Negative 1, 0, negative 5, 0. All right, there's what it's starting to look like. And then the next points are going to be 0, 10, and then the one across from it, let's see, it's 1, 2, 3 away from the axis of symmetry, so 1, 2, 3 away from it on this side. Yes, it's starting to look like a parabola, especially if I can draw a decent one here. Again, big hint, try not to make your parabolas look like V's. Try to make them look like U's, because they are U's. There are V-shaped graphs, but it's not these, okay? Good, that's starting to look pretty good. The one last thing I would mention, too, again, is realize these points right here were kind of like our zeros are our x-intercepts, right, on the graph. Well, that means that if we did try to factor this equation, we would get negative 1 and negative 5 as answers. Okay, and again, that's only just something to check in case you don't have enough points. Let's say, or you have your 5 points are really close together, and you still need a few more points to make a good shape of the parabola. Note that if you try to factor it also, that it should find your x-intercepts for you if there are x-intercepts. Let me just show that really quickly here. So if I factored out a 2, it'd be, because that's how I'd start this one, I'd get x squared plus 6x plus 5. And then if I tried to factor each of these, I'd get x plus 5 and x plus 1. What do you know? And so it all really equals 0, because I should have put in equals 0 over here. And yep, what do you know? Negative 5 and negative 1 would be my two roots. And that is literally saying, okay, when I put in negative 1 or negative 5, I get 0 in the equation, which is those points, which I see in this table. So it all connects nicely there, okay? Again, you'll see that you might not always have to use the factoring at the end. That's just maybe if you need a few more points and if it does actually factor. Okay, guys, I'll try to make videos typically short, but this being our first day back, this one is a little longer. But I think that will help, though, just to kind of review all the things we've been doing. But again, if you need more help, please let me know. Thank you. Good luck. Try the assignment, and let me know if you still need some more assistance.